Accident connection. Okay, am I live now? Should be right pretty much. Okay, live test audio, test audio, test audio. Okay, that confirms I'm live and let's go. Light गेले पण ठीक आहे थांबायचं नाही. So kth largest element in an array is done. So I just learned about heap syntax over here. It is used like this. By default it's max heap. Just mention the type of data, the underlying container, and the compare function. And I think false are kept on the top. So that's how the heap is built. Then just the explanation over here. Then I went into the heapify function, recursive thing. No need to learn for now, I guess. Just took a brief overview. Basically what it does is stores the level order traversal of the heap into an array, and that's how we can do. Then accessing the top k elements is a bit difficult in that thing, so I was trying to build over here a custom compare function and stuff. So kth largest element is successfully done. Then after this we have moved on to IPO. So my approach was to arrange according to the uh, decreasing profits and increasing capitals, and just pop from the heap, but doesn't work that way it seems. So let's just go to
IP.
Leetcode-Day2 and just take a look at it how it is supposed to be done, and let's see.
Hey
I hope this doesn't keep copyright. I hope. Fingers crossed.
everyone, welcome back, and let's write some more neat code today. So today let's solve the problem IPO. We're given two arrays. One array is the profits array and another array is the capital array. Suppose something like this where we have 1, 2, 3 for our profit values and 0, 1, 1 for capital. We're also given an initial capital called W, let's say it's 0 in this case, and we're also given an integer k, in this case 2, so you can see there's quite a lot of variables in this problem. Our goal is to maximize the amount of money, aka capital, that we have at the end. Initially we have 0. So what we would like to do is take some of the profits. So maybe we take 2 and we take 3. We can only take up to k of these values. And when we take them, we mean add them to our total capital. So if we start with 0, we add 2 to it, we add 3 to it, we end up with 5. So that's good. The only catch is that we can only take
Stream, I just have this call and come back. Hello. Yes. Okay, wow. That call was great. Let's head on to the IPO.
Take profits if the capital corresponding with the same index, so like these two, or maybe these two, or these two, if the capital corresponding to that profit is less than or equal than our current capital. We know we started where W was equal to 0, but as we take profits, our W value will change. So the profits available to us will also change. Though this part tripped me up, when we take a profit, we don't actually have to subtract the capital needed. This is not like the cost it takes us. This is the capital. So as long as our capital is greater than or equal to this, we are allowed to take the profit and we don't lose any capital ever. So once you get past all the variables and different kind of interactions, this problem isn't too bad. So what we're going to want to do is try to find the maximal profits. And we're going to need to do this repeatedly. So you might think we can sort the profits array or use a heap. In this case, using a heap is going to be better, and we're going to see that towards the end. So for now, let's assume we're going to use a heap for the profits, more specifically a max heap, so that we can get the max amount of profit. So let's be naive. Let's say this is in our max heap. We're going to pop the max value, which is 3. Let's say we also added the capital as well. So we see that this profit has a capital of 1. That is not less than or equal to our current capital. So we can't include this 3, at least not yet. So a better solution would have been to not have added this from the beginning to our max heap of profits. We should only initialize that heap with profits that we can actually take. This is the only one we can initially take because it's the only one with a capital of less than or equal to 0. Now let's see what happens when this is initially our max heap. Well, we pop from it. There's only one value to pop in the first place. There's only one value to pop. We get this profit of 1. We see the capital is less than or equal to our current capital. So we take the profit and add it. So we get now a profit of 1. So let's say we took this profit and now we can only take one more profit. The problem here, though, is that our max heap of profits is now empty. So what should we do? Should we go through the entire input array, obviously not this one, but the rest of the input array, and see which one of these profits can we now take and then push them onto the max heap of profits so that we can then pop from them? That would definitely work, but you can see in the worst case, every time we pop from the heap, we would then have to iterate through the entire array again and again and again. This is no better than iterating through the entire array k times. That time complexity would be n times k. That is a brute force approach, but the question is, can we do better than that? And the answer is yes, because we know that among the rest of the array, let's say these are the ones we couldn't afford previously, we didn't have enough capital for them, but now that we have increased our capital, and remember, our capital is never going to go down, it's only going to go up. Maybe it'll stay the same or it'll go up. It'll never go down. So as our capital changes, we might have access to more of these profits, but we don't know which ones. But let's say that this one actually required a capital of 2 and this one required a capital of 1. We know for sure that this one is probably going to become available to us before this one because it requires a lower capital. So among all of the ones we haven't considered yet, we should go through them in order of smaller capital and then bigger capital. AKA, we should maybe take all of these and throw them in a min heap, not based on the profit though, but based on the capital. If we do that, we won't have to iterate through all of these to know which ones have become available. We can look at the one with the lowest needed capital and check, is that capital less than or equal to our current capital? If it is, then we take this and pop it from that min heap and push it to the max heap of profits. So we're going to actually have 2 heaps in this case. This is a pattern that's used in other problems, though a little bit differently than this one, but it is a pattern nonetheless. But that's pretty much the entire idea. This problem is not too bad once you can figure out that it is a 2 heaps problem, which I admit is not easy to do, especially if you haven't seen this pattern before, because it is pretty rare. So now, how would we solve the rest of this problem? Well, both of these would go into our max heap of profits because we can afford both of them. But which one of them has a higher profit? It's this one. So we would pop this from our max heap of profits and then take that profit, which is 3, and add it to our current total. Then we would have a current total capital of 4. We're only allowed to take 2 profits. We took both of them. So then we would return this as our result. How did we improve the time complexity? Well, we're going to need to iterate k times. So the time complexity is going to be k times what's going to be the time complexity of pushing to max profits. It's going to be log n in the worst case. What's going to be the time complexity of popping from the minimum capital? It's going to be log n as well. We're going to, in the worst case, have to do 2 of these on every iteration of the loop, but that's not too bad. If we say this is 2 times log n, that will reduce to being k times log n anyway. So that is the overall time complexity. Space complexity is going to be big O of n. We do have a couple heaps. So now let's code this up. So what I'm going to do is first create our 2 heaps. We know one is max profit. Initially, let's set that to be empty.
This is a 2 heap problem. Min capital heap and max profit heap.
You know, these are only the projects that we can actually afford right now. And we're going to have a second heap for minimizing the capital. These are the ones that we can't necessarily afford right now, but maybe in the future we will be able to afford them. The way I'm going to initialize this is first as an array. So I'm going to go through every pair of capital profits that we have. In Python, you can do something like this. You can zip the 2 arrays, but you could do this in like an outer for loop, like down here if you wanted to. It's not a big deal. We have our pairs of capital and profit, and we're going to add each pair to this array. And then we're going to take that array and turn it into, this will turn into a min heap. So now we're going to iterate k times. So every single time we want to pop from the max heap, so the max profit heap, and then take it and add it to the current capital, which I'm just going to use the input parameter because that tells us our starting capital and we know it's going to change. So might as well add to it. And then at the end, we know we're going to return that capital, but we know that so far our max profits is empty. So we have to initialize it, and we know that every time we pop from it, then on the next iteration of the loop, we might need to pop from the minimum capital heap and push onto the max profits. So instead of initializing max profits out here, I'm just going to inside here, before we pop from it, I'm going to say while our minimum capital heap is non-empty and the minimum value in the minimum heap, or the root of that minimum heap, is at index 0. And we know it actually has a pair of values, capital and the profit. The capital, the first value, is what's going to be used as the key for this heap. So it's going to minimize all these pairs based on the capital. Since that's the first value, we're going to now say index 0. So we're getting the capital that is minimal, and we're asking, is this less than or equal to our current capital? Because if it is, that means we can pop from this minimum capital heap. And when we pop from it, we're going to get the capital and the profit. We added both of these, but once we pop them, we only care about the profit. The capital was only used to tell us, can we get this profit or not? If we can, then we don't need this anymore. So even though we popped it, we're not going to use it. We're just going to say this profit is now available to us. So we're going to push it onto the max profit heap. But the thing is, we want this to be a max heap. So we can't just push the profit because everything is a min heap in Python by default. So if we want this to be a max heap, we have to make this value negative. You can just say negative p.
So first of all, we'll have a priority queue of pair of incoming minimum capital and priority queue and of max profit. So pair vector of pair intended, and I'll have to have a custom function over here, right? So I'll go private struct compare operator, just like that, and then I'll const pair and ampersand a const pair and ampersand b, and we'll say return a dot first smaller than b dot first. So then it will go down, right? I'll check this, and everything is a max heap by default, right? Yes. So say a is greater than 0, right? Yes. I'll save that project while not main capital child of empty, and this should be true. W greater than equal to man capital dot top dot first for equal to 0 smaller than profit stock size x plus and capital equal to data ready. So I'll first pop, and I'll say project running capital.pop and then capital.pop, right? And I'll just now profit.push and push project.second. So now all the visible max profits are done. So while again here w plus equal to max profit dot top and max profit dot pop and k minus minus, and I'll just print w over here. Beautiful, this is working. Yeah. So in this case, this will go on, but this won't do the updation, right? So feasibility, right? So first we'll do a feasibility check. Yeah, this one then I'm going to put a W. Easy by is equal to true. If not is equal, then W.
or -1 times we're trying to add to the capital and we want the capital to be positive. When we pop from here, we're going to be getting by -1. Or remember that we don't even have K profits available to us, in which case this would throw an error. Try max at that point, because if none of the profits are available,
Yeah, needed quite a bit of help, but that is fine. Then move on to our next question. APRs. Small. Okay, I believe this is straight up heap question where we have to compare the const compare struct again. So basically what we'll do, we'll have heap with all the possible player pairs, and possible pairs will generate a sequence, then we'll just append it to the heap. Basically now appending to the heap, we'll just pop top k and we'll just return it. Let's see, I think that might be a better way because there's non-decreasing auto given over here, so something like a window and stuff like that. But for now, let's keep it fine. So let's, what was it? So compare, there is a constant of and const and ampersand b. So we will receive an a and b. What is the obvious given? Nothing, right? Okay. After receiving a and b, it should return if a dot first plus b dot, sorry, a dot second is what, then b dot first we want the smallest, right? So we'll return if it is bigger because the falses are on top. Then we'll move on and we'll say priority queue. That will have pair of int and int. Also, it will have vector of pair of int and int. And we'll have here is compare. I will say heap. And for okay, I is equal to 0, I is smaller than nums1 dot size I plus plus for int j is equal to 0 j nums dot uh, solution for int I tar is equal to 0, I plus minus yeah, I tar plus plus, and I say pair of int int let's say sample equal heap dot top heap dot pop as well, and we'll just append in solution dot push back where sample dot a lot of clash between Python and C++ going on in my mind. Okay, this is running fine. Let's just try and submit. Might be time limit exceeded, but I don't know. Memory limit exceeded. Okay. Of course, they had to give me big arrays. While pushing, right? Not decreasing. So I'll just push it in way like and size 1 is equal to nums1 dot size and size 2 is equal to nums2 size. So I'll say while say and count is equal to 0 simple count smaller than k and p1 is equal to 0 and p2 is equal to 0. size 1 and p2 string size 2. Okay, this is the thing. Mm, okay, so nums of p1 plus nums 2 of p2 is more than equal to sum. Then I'll just say heap dot push nums 1 of p1 nums 2 of p2. Else now I'll have to take the minimum, right? So either I can move too many things going on in my mind. This live stream will be done. Just 40 minutes, so that is fine. What's the black thing? Just copy this and reload this once. I don't know what the black thing is coming up. Okay, so we have it. Someone will go to max. So either we move the left pointer so we do this sum1 is equal to p1 plus 1 and we just keep it like this. If p2 size minus 1, then we do sum2 is equal to nums of p1 which is already valid plus nums of p2 plus 1. Then we compare sum one, if someone int max and sum2 equal to int max, then just click it off. If someone greater than sum2, then I'll just say p1 plus plus, else I'll say p2 plus plus. To my grave. Let's try and get some help from the GPT. What is this? I have no clue. I'm just stopping this stream right now. There are too many things going on. Bye for now. I'll continue this for sure.